Hello class, this is a video tutorial on mixed trigonometry problems. For all of the rules or formula used in trigonometry, it's best to understand that calculations boil down to essentially finding three different things. We are either finding a missing side, a missing angle, or the area of a triangle. Once we know what is being calculated, the appropriate method can be more easily determined. So in my mind, I have these different flowcharts. So either it's a missing side, a missing angle, or calculating the area. In these sets of examples, I won't be covering this one as much because it's very obvious when an area needs to be calculated. It'll specify the area. So just understand that when we're calculating the area, we determine whether it's half base times height or using the sine area formula. So keep that in mind. But notice when it comes to the missing side or angle, it actually feels much more daunting trying to figure out which one it is. But as you can see, once we know it's whether a side or an angle, the next question I ask is the triangle given right angled triangle? Then I go if yes or no, and then I determined which of the rules it is. You can pause and reflect and take a look at this method or this flowchart if you'd like, but I'm just going to go straight into doing this in action. So here we go to the first three examples. So in all of these triangles, let's find the missing pronumerals answered to one decimal place or to the nearest minute. I have 9 examples here, and we'll do 3 at a time. So here we go. Part 1. Let's observe this triangle here. And you can see that the missing pronumeral is this value here. Now, if you take a close look, you ask ourselves, is this a side or is this an angle? Well, side lengths are always on the edge of a triangle, whereas the angles are almost always on the inside of this triangle. So this is an angle. Let's take a look at which one we're dealing with. So notice it is now a missing angle we're working with. So let's zoom in here. Now ask ourselves, is this triangle right angled? As you can see here, there's no right angle here. So this is a non-right angled triangle. So no, this is not a right angle triangle. Now we ask ourselves, how many angle side pairs are there? Now remember, in non-right angle triangles, we have sides paired with its angle. So this is one pair, and this is another pair. Notice how there are two angle side pairs. So once again, one pair, two pairs. So that is going to be the sine rule. Now take a look, since we're going to do the sine rule. Let's now follow exactly what it says. Sine A. Now A is going to be the missing angle. So sine theta over A. So the matching side to this is 12.8. So sine theta 12.8 equals, sine B is the other angle that we have. So sine 47 over the matching pair B. So in this case, B is 15. From here, it's just a matter of solving for this missing angle. From here, we multiply by 12.8. So we get sine theta equals 12.8 times sine 47 all over 15. Then from here, remember now, when it comes to missing angles, there will always be an inverse sine or inverse cos or inverse tan step. In this case, since we're trying to find the missing angle, we need to do, of sine, sorry, we do theta equals inverse sine of everything we've just written. So 12.8 sine 47 all over 15. And that is what we type into our calculator. Let's type that in. So inverse sine fraction 12.8 sine 47 over 15. You can see here it's 38.615, but we want this to degrees, minutes, and seconds. So theta to the nearest minute is 38 degrees, 37 minutes. And that is the first problem. Let's now apply this series of steps to the next one. Zoom out here. Here we go. Now let's take a close look again. What is being calculated, or what needs to be calculated in this triangle? Whereas you can see, the edge has the letter, so this is a missing side. So we're zooming in on the missing side. Then ask ourselves, is this a right-angled triangle? Take a look. Well, there's a right angle here. So yes, this is a right-angled triangle. The next question is there a reference angle? Meaning, is there an angle given? Well, take a look. There's an angle here. Well, since there's an angle, we're not doing Pythagoras theorem. It's a yes, there's an angle. We're now doing so, ka, or toa. So zooming in here. Now it's just a matter of figuring out, is it sine, cos, or tan? Well, for here, as you can see from the angle, we have opposite and the hypotenuse. That is going to be sine, so, ka, toa, so so. So this now is going to give us sine 33 equals x over 8. We want x on its own, so multiplying by 8, we get 8 sine 33 equals x, and that is what we type into our calculator. Calculating this. So 8 sine 33, that gets us 4.357, rounding off to 1 decimal place for this one, answer to 1 decimal place. This gets us 4.4. Now in this problem, there is no units of measurement, so let's just say 4.4 units, and we'll leave it at that. Okay, so let's zoom out again. Let's apply it one more time for this video. Let's take a close look again. So in this triangle, take a close look at the pronumeral. That is an edge. So that is a missing side once again. So zooming in on missing sides. Now, is this triangle, is it a right-angled triangle? As we can see, there's no right angle here, so the answer is no. So zoom into this. And then we ask ourselves again, how many angle side pairs are there? So remember, angle side pairs are side and angle. That's 1. And we have side and, oh no, in this case, there is no angle here. We have 1 angle side pair. So this will be the cosine rule. So applying the cosine rule now, now it's just a matter of, if we remember how to use this formula, it's just now figuring out where these letters belong, where these letters belong in our formula here. So in this one, we want p to be the missing value, so p squared equals a squared plus b squared. In this one, c is this one. So a and b close off the angle. So in our problem here, a and b, those close off our angle here. So a squared and b squared are 18 squared plus 25 squared minus 2. I'm following the formula here, minus 2ab. ab is 18 times 25 times cos c, so times cos of 23. Just typing all of that in now. 18 squared plus 25 squared minus 2 times 18 times 25 times cos 23. Cos 23. That gets us 120.545 dot 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 dot. But remember, that is just p squared. To get p on its own, we take the square root of this value. And in the calculator, that's simply taking the square root, square root of the previous answer. Whoops. Oh, goodness. I need to type it in again. My apologies. Square root of 120.545. This is not going to give the most accurate because there were more decimal places. But for the sake of the time, understand that you need to substitute all of the decimals possible in the square root. But for this, let's just summarize it as 10.97, but that rounds up to 11.0 units or centimeters or whatever it might be. So I hope that's already giving you an insight into how we can use this flowchart to determine which formula to use. Hope to see you in the next video where we tackle the next sets of problems. Hope to see you then. Best of luck.